So today is 11/5, and stay focused. Okay, we're dealing with choosing data displays, and the reason why I gave you this sheet on the way in is because it has a list of a bunch of data displays. Okay, it kind of gives a brief summary of each. Pretty brief, but you have your circle graph, and keeping in mind a circle graph is good to show percents in relation to the whole. So your percents add up to 100% here. Okay, it's a great way to compare using a visual. You have your box and whisker plot that we've talked about. Remember, you have your 5-number summary there. It gives you those 5 pieces. Okay, it doesn't show all the data, which is one of the problems of it. So this sheet also gives you some kind of downfalls. It doesn't show all the data. And then keep in mind that each section of the data represents 25%. So this is a nice, real brief summary of each of these. So if you're taking notes, something you want to study or reference, it's a good page. Okay. Third one is stem and leaf plot. You have your stems. You have your leaves. Okay, this is 33. This is 38. 38. 38. That's what the key's telling you. It says 5 with your line 6 represents 56. That's what that key means. Okay, the benefit of this one shows all the data. It also, if you do it in a nice way, it almost gives you kind of a bar graph, like a side bar graph. You can see where most of your data lies also. Okay, a frequency table, just as a way to organize data. Please note that all these intervals are the same. They have the same distance. Okay, it's a great way to organize it in groups, and it's helpful when actually building a histogram. Okay. Histogram or a bar graph, remember the difference is in the histogram you have intervals here, so maybe you would be graphing these intervals. Okay. This is a bar graph. It's a good way to compare data. Helps you to see the frequency in terms of your height of the bars. Okay. Line plot is just a nice visual, shows all the data. So you have 1, 2, 3, 4 2s, 1, 1, 3 3s, 1 4, and 1 5. Your data table, one that you've used a lot. It shows all the pieces of data. That's the benefit there. Organized list also shows all data. The list is organized. You can make it a little more organized by actually putting it in numerical order. And your scatter plot. Okay, bivariate means there's 2 variables, the x and y variable. Okay, it helps you to see those trends. Okay. Yes. Usually, when you could have just a graph, like a line graph or a exponential graph. That's fine. Yeah, but these are more in terms of data with statistics. Okay, so the different categories that we have in terms of checking out data, we have qualitative data and we have quantitative data. Okay, qualitative is more of a category, whereas quantitative, it measures numerics. It has numbers involved. Okay. Oh, thank you. Yeah, there's numbers involved with quantitative. Okay? Qualitative consists of more labels, non-numeric. Okay, so you have those labels, non-numerical entries that are separated into categories. So for instance, going back to our example here. Okay, this right here, you have measurements of days. Okay, and you're measuring the number of pizzas each day. Okay, you have, in that case, you have quantitative or do you have qualitative data? Talk to your neighbor about it real quick. Quantitative or qualitative, looking at that first graph there. Okay, what do you guys think? Qualitative? How many say qualitative? How many say quantitative? You got to vote. Don't just look around and pick someone else's. How many say qualitative? How many say quantitative? Okay, are you measuring an amount in this graph?
Yes.
Yes, you are. Okay, this is quantitative. It's a quantity because you're measuring the number of pizzas ordered each day. Okay? We will see some examples of qualitative here in a while. All right? Very good. Misleading graph. There's some misleading graphs. I'm going to have you copy some stuff down from your book here. I'll put the information up. Okay, when we're talking about misleading graphs, maybe list page 620 as a nice reference here. Okay, misleading graphs. I'm going to give you a minute to read that to yourself there. Okay, so those are things you're looking for when you're dealing with a misleading graph. Someone's trying to lead you into thinking something or selling you something or getting you to believe something based upon misleading data. The way the data itself may not be misleading, but the way they're presenting the data to you may be misleading. Okay, they're trying to make it appear as though something else is happening than what it actually is happening. Okay, so some things to ask yourself: is the graph have a title? Okay, are there labels on the sides? Are the numbers of the scale evenly spread out? So you're going up by a constant interval. Does the scale begin at 0? If not, is there a break? Okay, that's a big one. A lot of times graphs you'll see don't begin at 0, therefore the data appears to be twice as much or 3 times as much, and it's only a fraction of that. Does the graph need a key? Okay, are the axes or sections labeled? Are the components of the graph, such as bars, the same size, or do they make them wider or narrower? Taking a look at this graph right here, notice the y-axis doesn't start at 0. But if you just look at the bars, you would say, well, hey, right here and right here, this bar is like twice as big as that one. Right? Whereas when you really look at it, this represents about 16,500 and that represents about 18,000. That graph's misleading. It's misleading because if someone just does a quick glance and just kind of looks at the links of the bars, this one looks twice the value. Okay. Right now, especially with a lot of the ads and the campaigns, you start looking at people running for office, or if you kind of look at like maybe cell phone companies or cable companies that are advertising against each other, when they put something on the screen and it's right in front of you just for a second, you just take that data as being something that's truthful, and you don't actually analyze it. A lot of times the data is misleading. It's for their point of view. Okay, they're trying to get you to buy their product or vote for their person or do something that they want you to do. So you need to make sure that you're paying close attention. Okay, notice this one right here. Go ahead and look at it. Tell your neighbor what's wrong with that graph.
It goes from 0 to 8.9, and then it goes to 8.92. This goes by 2 seconds, but it goes from 0 to 8. So it looks like it's like going up, but it's not like that.
Okay, so where was the greatest increase? Between what 2 years?
12 to 2012.
2009 to 2010.
You can't really tell.
2011, 2012, everyone agree?
No.
So from 11 to 12, that was the greatest increase?
No.
2012 to 2013.
It does look the greatest. I mean, it goes up how much? From 9 to 904, so 4 cents. Okay. How about, so is that the biggest? No, where is it?
Yeah, see 2009, 2010.
2009 to 2010 actually went up how much?
4.5 cents. 6 cents.
Went from 8.93 to 8.98. Went up 5 cents, right?
I was the only one that
I did hear that. Hey, so what's wrong with this graph? I know it's misleading, right? This one looks the biggest. Why is it misleading? What's happening? Kai? Yeah, it's not going up by the same amount. Okay, you're not going up equal intervals. All right. Hey, so it's easy to make. I could have just presented that to you. You guys would be like, yeah, dude, what a good year. All right. 4 cents. Sweet. All right. Good stuff. Okay, once you take a look at page 352 of your student journal, please. Once you go ahead and work with your groupies, questions 1 through 4. Quantitative, qualitative, explain. Isaiah, number 1. Bookmarks in the web browser, quantitative or qualitative? Qualitative? Okay, Brian, how come? What's that? Yeah, it's a label. Okay? Good way to think about it. Bookmarks are non-numeric. They're labels. Okay, non-numerical. They're labels. I guess we should say actually what's non-numerical. Bookmarks. Okay. Number 2, heights of players on the basketball team. Sergi, what do you think? Quantitative? How come? Yeah, it's measuring. Okay. Heights are numerical values. Okay, Tyler, number 3, number of kilobytes in download file. What's that? Quantitative? How come? I messed up here. I misspelled that. Okay, I'm sorry. The phone distracted me, Tyler. What'd you say? You don't know? It is quantitative. How come? Gunnar, help him out. How come it's quantitative? You don't know either? Oh, man. Tough life. Oh. A bunch of people that want to help. All right, Cass. Numerical values. Okay. Number of kilobytes is numerical. It's true. Okay. Hey, I want you guys to tell your neighbor what you got for number 4.
Qualitative.
I got qualitative.
That's what you gotta get ready for, man. It's the Yoda bites.
I just say qual.
That's like
Quad and qual.
All right, Bella, what'd you get?
it's like
Quantitative?
it's like
How come? Jilly, how come?
it's like 9 to a week or something.
Radio station numbers are numeric values. However, yeah, this is qualitative. This is qualitative because they're labels. Yeah, they're numeric, but they're labels. Like a radio station. What radio station do you listen to? Okay, that's a label. Okay. Okay, number 5. Jonathan, I'm going to take the Chromebook. You're not going to get it back until the end of the day. Thank you. Okay, number 5. Best display. Use your 9 displays I gave you on the way in. Figure out which is the best way to display that data. You think. Could vary. Hey, pick a data display and draw it. Give it a go. I'll show you the one I used once you're done. Hey, ladies and gentlemen, volunteer on what they chose. Yeah. Double box and whisker plot. Any others? Yeah. Okay. Stem and leaf plot. Any others? Hey, by the way, if you're doing a stem and leaf plot, like a double stem and leaf plot, you could put all the stems. Do we have 5? We should have 5 and 6, right? Okay, so you could put all the stems like that. And then on one side, you'd have Babe Ruth, and the other side, Hank Aaron, or so on. Okay, so like maybe Babe Ruth on this side, and Hank Aaron on this side. Okay, so you could have it, you could go that route on it. If you did your double box and whisker, we've seen that before. What's the benefit of doing the box and whisker?
You see like where it's skewed and like
Yeah, you see this, see where it's skewed? Yeah. Yeah, you'll see the 5-number summary. Okay, you'll be able to compare maybe a little more. That would be, there's an example of a double box and whisker on that one. That's what I would have chose. Okay. It allows you to see who had the maximum, who had the highest number, where the greater range was, okay, how the data was clumped over the course of time, and draw some conclusions based upon who you might think was the better home run hitter, okay, over the course of time. Okay? Yes?
pie.
Yeah, you want to pick something where you can compare two graphs easily.
I like pie.
Okay, so you could do a double bar graph if you wanted. There are multiple displays, but probably not a good thing for maybe a circle graph or something like that. Okay. Okay, want you to turn to page 353, please.
Oh look, it's already there.
All right, number 7 and 8.
Yes.
I want you to complete those two. Okay, volunteer. Why is the first one misleading? Oh, not enough people know. We'll go back to it. You guys figure that out. Volunteer again. Why is the first one misleading? Need at least half of you to figure it out. Start talking about it. Here we go. All right, volunteer. How come? We're getting closer.
Oh, hey.
Hey. Bella, what do you got? No. Yeah?
Because the intervals on the are like equal.
Good. The intervals are not equal. Okay? This one goes
How did I still
0 to 59. This one's 60 to 89.
No, I don't listen to you talk.
Nobody listens to you talk.
All right.
Well, it's hard not to hear you
Focus
talk.
back up here. Relax. Okay. What's wrong with number 8? Brian? Yeah. Starts at 60 and not 0, meaning you're misleading with the bars, right? Carol has 70, whereas Bob has 90. Looks like Bob has over twice as much as Carol, which isn't true.